This video is on heating and cooling curves.
A diagonal line on the graph indicates a change in temperature, whether the substance is heating up or cooling down. In this case, the substance water is heating up. This is also the change in kinetic energy.
The formula for temperature change is Q equals mc delta T. Q is the amount of heat lost or gained. This is measured in joules. M stands for the mass of the substance. C is the specific heat or energy required to raise 1 gram by 1 degree joule. There are special constants for water that will be explained later in the video. Delta T is the change in temperature, which can be calculated by doing T final minus T initial. It is measured in Celsius.
The straight lines on the graph indicate a phase change. In heating curves, a solid may turn into a liquid or a liquid may turn into a gas. In cooling curves, the gas becomes a liquid and the liquid becomes a solid. There is no actual temperature change during this phase. This is also the change in potential energy.
The formula for phase change equals Q equals mH fusion for solid or liquid, and Q equals mH vat for liquid and gas. Energy is required for phase changes. Q is the same as in the temperature change. It is the amount of heat lost or gained. M still stands for the mass of the substance. H vat is the heat of vaporization. H fuge is the heat of fusion.
There are special constants for water. Liquid water is 4.18 joules per gram degree Celsius. Ice is 2.05 joules per gram degree Celsius. And steam is 2.02 joules per gram degree Celsius. H vapor is 2,260 joules per gram, and H fusion is 334 joules per gram.
Another thing to note is that ice melts to liquid water or liquid water freezes to ice at 0 degrees Celsius and liquid water evaporates to steam, or steam condenses to liquid water at 100 degrees Celsius. Next are some important definitions that you should know will be useful for this unit. Temperature is the average kinetic energy of all of the molecules in a sample. It is a measurement of how fast the molecules are moving. Absolute zero is 0 Kelvin, which is negative 273 degrees Celsius. This is the point where all motion ceases.
Heat is a form of energy that flows between two samples of matter because of their differences in temperature. The law of conservation of energy states that all energy cannot be created nor destroyed, but it can be converted or transformed.
Let's work on an example problem for sketching a heating curve. The problem states, sketch a heating curve of 850.0 grams of ice at negative 55 degrees Celsius, heated to water at 96 degrees Celsius. Calculate how much energy is required to do this.
The first thing you should do is sketch the heating curve and label each part of the curve. It should look like the curve shown here, going from negative 55 degrees Celsius to 96 degrees Celsius. There should be a straight line at 0 degrees Celsius because of the phase change between solid and liquid. You should have 3 steps.
For step 1, you should use the equation Q equals mc delta T and plug in the given information into the variables. 850.0 grams is the mass of the water, so plug in 850 for M. Since the substance being heated is water, we can use the special constants for C, which would be 2.05 joules per gram degree Celsius in this instance, because the current state of the substance is ice. Next, we find delta T, which is the initial temperature subtracted from the final temperature. The initial temperature is negative 55 degrees Celsius, and the final temperature is 0 degrees Celsius. So, 0 minus negative 55 degrees Celsius equals positive 55 degrees Celsius. Finally, multiply 850 times 2.05 and 55 all together, and you should get 95,840 with significant figures. Always add the units, which is joules.
Since step 2 is a phase change, you should use the equation Q equals mH fusion. because the graph indicates a phase change between solid and a liquid at 0 degrees Celsius. The mass is still 850.0 grams, and the H fusion constant is 334 joules per gram. Multiply the two together, and you should get 2,839,000 joules with significant figures.
Step 3 is similar to step 1, as you use the Q equals mc delta T equation and plug in the given values. 850 grams for the mass and 4.18 joules per gram degrees Celsius for the special constant of the liquid, and 96 degrees Celsius for the change of temperature. After multiplying all three numbers, you should get 413,850 joules.
The last step is to add all the Q values from each step to get the total amount of energy needed for the heating curve. Add 95,840, 283,900, and 413,850, and you should get a total of 413,850 joules. You do not need significant figures for this step.
Now try problems number 1 and number 2. Follow the same steps you did for the example problem. Number 2 is a cooling curve, but it follows the same steps as the heating curve. The answers for each problem can be found below the question.